Dear students, welcome to my 4th class on Module 1, Laplace Transforms. In this lecture video, we want to discuss about unit step functions and problems on unit step functions. What is unit step functions? So this function is also called as an Heaviside functions. The following is a function which shows up often in engineering, that is h of t minus a or u of t minus a is equal to 0 for t less than or equal to a and 1 for t is greater than a. This is named after the British electrical engineer Oliver Heaviside. In literature, it is also named as an unit step function. The best way to understand this is to draw a graph of this function. This is also an discontinuous function, and clearly it is like a switch which comes at time t is equal to a. Also draw the graph of the function like f of t into u of t minus a and f of t minus a into u of t minus a to understand the role of the step function in better. So in this example, take f to be t or sin t or cos t. So the important result from the point of view of this course is Laplace transform of f of t minus a into u of t minus a will be equal to e power minus as into f of s. If the given function has a discontinuity at a, the following trick is useful to find its Laplace transform. That is, let f of t is equal to f1 of t for t is less than or equal to a, and it is f2 of t for t is greater than a. Then f of t will be equal to f1 of t plus f2 of t minus f1 of t into u of t minus a. In the same way, the above trick may be used when there are more points of discontinuities in the function. So like let f be a function with 3 points of discontinuity. Let f of t is equal to f1 of t for 0 less than t less than or equal to a, f2 of t for a less than t less than or equal to b, and f3 of t for t is greater than b. So in this way, that f of t will be equal to f1 of t plus f2 of t minus f1 of t into u of t minus a plus f3 of t minus f2 of t into u of t minus b. Problems on Heaviside functions. The first example, find the Laplace transform of e power t minus 1 into h of t minus 1. So here I'll be choosing the function f of t minus a is equal to e power t minus 1. So we can say that a is equal to 1 here. So now I'll be converting this f of t minus 1 in terms of f of t by replacing t is equal to t plus 1. So we got f of t is equal to e power t. Now I'm going to apply Laplace transform for this function. So we'll be getting the equation like this. Laplace transform of e power t minus 1 into h of t minus 1 will be equal to e power minus s into Laplace transform of e power t. This will be equal to e power minus s by s minus 1. So in this problem, we'll be applying the formula Laplace transform of f of t minus a into u of t minus a is equal to e power minus as into f of s. So that formula will be applying here. Example number 2. Find the Laplace transform of t square into h of t minus a. So now the first thing is to choose a function f of t minus a. So here f of t minus a will be equal to t square, and by seeing the problem we can say that the value of a will be equal to 2. So therefore we can consider that f of t minus 2 will be equal to t square. So now we need to convert this f of t minus 2 in terms of f of t. So just I am replacing t is equal to t plus 2. So we'll be getting the equation like this. So t square is equal to t minus 2 plus 2 whole square. It will become t minus 2 whole square plus 4 times of t minus 2 plus 4. So just writing t square in this form after expansion of this equation. So now we can write this f of t will be equal to t square plus 4t plus 4. So now the Laplace transform of f of t minus 2 into h of t minus 2 will be in the following form. That is, Laplace transform of t square into h of t minus 2 will be equal to Laplace transform of f of t minus 2 into h of t minus 2, that is e power minus 2s into Laplace transform of f of t. So now after applying the formula for this f of t equation, we'll be getting e power minus 2s into Laplace transform of t square plus 4t plus 4. So we'll be getting e power minus 2s into 2 factorial by s power 3 plus 4 into 1 by s square plus 4 into 1 by s is the required solution for the given problem. Example number 3. Find the Laplace transform of f of t is equal to cos t for 0 less than t less than or equal to pi and sin t for t is greater than pi. So here I am going to use the second formula. So first I will be rewriting this discontinuity function. So like I can use a formula that f of t is equal to f1 of t plus f2 of t minus f1 of t into u of t minus a. That formula I'll be applying here. So by observing the problem, we can take a is equal to pi here. So therefore, we got f of t is equal to cos t as f1 of t plus sin t minus cos t as in the place of f2 minus f1 into h of t minus pi. So a is equal to pi. So now I am going to apply Laplace transform for this equation on both the sides. So after applying the Laplace transform, we'll be getting Laplace transform of f of t is equal to Laplace transform of cos t. Directly we can solve Laplace transform of sin t minus cos t into h of t minus pi. So in this step we have to apply the formula. So as you know that Laplace transform of cos t will be s by s square plus 1. So here I am going to use the Heaviside function formula, that is Laplace transform of f of t minus a into u of t minus a is equal to e power minus as into f of a. So we can know that here a is equal to pi and I am choosing this complete part, this sin t and cos t as f of t minus pi. So now our job is to convert this f of t minus pi in terms of f of t. So I am just replacing t is equal to t plus pi on both the sides of the equation. So we'll be getting sin t is equal to, so sin t plus pi, so sin t plus pi will be, again it is plus sin t only, and again converting cos of t in terms of cos of t plus pi, it will become minus cos t. So we got the equation like Laplace transform of f of t is equal to Laplace transform of cos t plus Laplace transform of minus sin of t minus pi into h of t minus pi plus Laplace transform of cos of t minus pi into h of t minus pi. So after applying the main formula of Heaviside function, so we'll be getting the equation like this, that is Laplace transform of cos t plus e power minus pi s into Laplace transform of sin t plus e power minus pi s into Laplace transform of cos t. So on simplifying further, we'll be getting the solution is s by s square plus 1 plus e power minus pi s into 1 by s square plus 1 plus e power minus pi s into s by s square plus 1 is the required solution for the given discontinuity function. Okay, in the next lecture video, we'll be discussing the inverse Laplace transform and problems on inverse Laplace transform. Thank you.